if you were in an interview, could you tell me what a kernel is? And this is actually an interview question. And if you couldn't tell me what a kernel is, could you tell me what an operating system is? All right. So
Op-
those are some.
operating
Oh, go
system.
ahead. Go ahead.
An operating system would be a set of instructions in binaries, giving instructions to the computer to make some actions.
Okay. And then what will be a kernel?
I would say that it's the core of that operating system, which maybe does the basic functionalities of interfacing with drivers, for example, and different hardware.
Close. The second part is more accurate. So really, what the kernel is a part of the operating system, but it is the lowest level in which it interfaces with the hardware. And I have notes for that, but that's on my computer, my other computer that's actually rebooting right now because it's doing a nice little install. So the reason why I bring this up is because one and two, those are interview questions. So if you ever want to know what interview questions that Linux people get asked, that's two questions that get asked. So another question that gets asked is the kernel subsystems. This is a question that gets asked as well. Why am I bringing this up? Because one, it's an interview question, and two, this is just something that I think overall you should know. I had a link, and I don't want to get into like searching for links here, so let me look and see if they have something that I could. Let me scoot over because I think this is going off the screen here. Is that on the screen for you right here? All right. So here's a good one. Let me send you this link. Let's see. Is it on there? When I minimize, is this better?
Yeah.
Okay. All right. And this is a pretty big document here. If we wanted to break this down, but in some of the interviews I've had, just in when you're talking about, say, I deployed an application, and the application is using up CPU. How do I determine what process or what is going on, why it's using up that much CPU or why it's using up that much memory, what's causing the system to fail? So understanding, some things that happen. Say you have this, and this is speaking from a bare metal perspective as well. You upgraded the operating system on a bare metal machine, and you moved from CentOS 6 to CentOS 7, or you installed some new drivers. Sometimes the drivers could cause a failure. Sometimes it could be that you've upgraded and what you used before is using a different type of library. So it could be something there. It could be that you have a bloated kernel. It could be that you have the wrong kernel. It could be that you've partitioned. You didn't use enough the way we break it down when we're partitioning our drives, we use the wrong type of file system, or we partition it wrong, or we don't have enough inodes. It could be a number of things, but how do you come up and determine what the problem is? So understanding the low level stuff goes a long, long way. And I applaud like the Linux Academy for some of the things that they have, but some of this is not even taught inside of the Linux Academy. I looked around for some of the courses that they had. I didn't see from a Linux perspective when it comes to looking at the kernel and breaking things down with drivers and so forth and so on. I didn't see that. So I know they have the RHCSA. I have not taken the LPIC. If some of you have taken the LPIC classes, that probably would help. But I'm not sure if those classes cover, excuse me, that in depth of getting down to the kernel. All right, so one person that I want you all to uh, note is Brendan Gregg. Whenever you want to know some Linux performance stuff, this is a good site. And I'm going to blow this picture up here. I hope it doesn't expand too much. Can you see this?
Yeah.
Okay. All right. All right. So let's look at some things, and I need to get a terminal. And I'll get a IP address here, Dark. Excuse me, pretty soon. All right. So if you look here, I'm looking at firmware right here, and I'm looking at drivers. And then this is right here is what we're talking about, when we're talking about making up the operating system, but then the kernel interfaces with the hardware to say, okay, at this memory address is where this, and you'll see this we'll probably cover this the next time. I may cover it today if I get time. You'll see this like if you go and start looking at D-message. I need to get one. I need to open up a terminal. But you'll start seeing this like what's covered. Like if you do an LSPCI, you'll see where things are located at, what the hardware address is, where your mouse is located at, where your Ethernet port or Ethernet is located at. You'll get all these different type of messages, which is really cool. Let me see. I'm on a Mac and I should be able to run. They don't have that. Let's see. Oh, they do. But this is not my Mac. Yeah, so I'm not gonna be able to do that. I had to get on my Linux box and do that. Paloma posted some stuff, some super helpful to prepare for interviews.
Yeah, it's
Go
a
ahead.
video course by Sander van what?
Yeah, Sander Van.
Yeah, he's
Yeah.
from Netherlands.
Yeah.
But he writes most of the certification books, both
Mm-hmm.
for LPIC and the Red Hat exams. That course went like deep into understanding the kernel, understanding scheduling, understanding memory management, all that stuff. So I highly recommend it.
Which course was it though?
It's called Linux Under the Hood.
Oh, okay.
Oh, it didn't take you.
Nah, it didn't take me there. It kept opening up to something else, but that's okay.
Okay.
You're talking about this class.
Yeah.
Let's scroll down.
If you have Safari books, you can
Hmm.
see.
And I think some of the share slides they may be out there for free for this class. But yeah, in here he talks about Linux commands, how they work, understanding the boot procedure, which is another question on in another interview question. Understanding the process. My favorite question is if you had to look at top, could you break down what each one of these segments mean? The process, the low, average. It used to be what was the last process to run with the be process ID 1 and it tab be the last process to run. Memory, and then there's also HTOP. Oh, it's not on here. So on a Linux box, you could get HTOP. So the other one is you see right here where we start talking about performance and optimization. That's another good class, another good uh, interview question, and that leads back to this over here. Like if you're looking at CPU, what utility you would use in order to figure out what's going on with CPU. What does slash proc give you? How do you find out how much memory you have on a system? How much memory has been used by a particular process? How to do an S trace? That's another one. Breaking down what an S trace does. I think this one is a little bit beginner friendly here. I'll post this link. And then breaking down, like you can do going like I've gotten questions like, what's the first line of an S trace and what does it mean? Now, granted, I think that's obscure, but I guess if you're doing it every day, you would know what those mean if you're doing it every day, if you're troubleshooting every day. Now, when do these type of questions come up? Well, what I found is these type of questions come up when you're in a larger environment, when you're actually troubleshooting information or troubleshooting instances all day. So when I say a bigger environment, I mean like a AWS or a Google or a Bloomberg, or like really huge shops, or you may have a one-off where you're working with some developers or something of that nature to figure out, what's causing this spike on this machine, or why is it running slow. But I have not seen it where I'm using it every single day to find out what a problem is. What I and that again, that's the environment dependent. What I have seen every day is Python, Ansible, Bash, Chef, or Salt. Is the latest and greatest I've been getting from different people using Salt, because it does everything that Chef and Puppet does all in one. So a lot of people are using Salt. A lot of people are using Chef just for configuration management, and then Salt for doing everything else on top of that. So it's been a combination of those things: Salt and Chef, and then Puppet by itself. Um, the other things that have come up are microkernels, and I'm not sure if you're familiar with that. So we have microkernels, and I want to show you this with Puppet as well. Any questions? All right, so in my discovery with like figuring out like what's the best way to use Puppet with bare metal, I came across their project called Razor, and I'll send this over as well. But this is not the link that I wanted to show. It may be straight on the Puppet site. Where did you go? It may be that one right there. Here we go. The version of it is no longer under development. You gotta go to GitHub. I guess it's here, but I wonder if they break it down. Installation. No, let's go back. There was a picture of it, and that's what I wanted to show. Let me go to images. There we go. That works. So basically, for me doing my analysis on this and reading it, it's basically like you need a TFTP server, kind of like a Kickstart machine, like you would be setting up a Kickstart machine, and it goes out and it boots up into a microkernel, and you can set it up based upon the MAC address. And then once it gets the MAC address and the microkernel, you can say, okay, when I get this MAC address, install this microkernel. So you're asking like, what is a microkernel? She keeps saying that, but Shen said exactly what it was. And I had a microkernel definition versus just the regular bloated kernels. So what I got from reading, I was going to send you these links. I'll post these links as well inside of the like a review out on meetup.com, and I'll email it to you. But what I've gotten from my knowledge of reading about the microkernel was the microkernel does less context switching. Well, it does more context switching in a smaller domain. So let's look up kernel context switching. And that's usually like what the kernel was doing. And let's see, let's give you this so you can read this later on, because that will be important. And hold on 1 second. Hold on 1 second. Read that for a second. Hold on 1 second. All right. I think see, the Slack is up. Let me see. Let me see. No, that's not
It's going
it.
to be in the one you send me. It's going to be in yours.
Oh, okay. There we go.
Don't let everybody see the wacky stuff we send to each other.
You be all right.
I don't want to be found out.
Everybody know. Everybody know you're a thief.
I'm not a thief.
Everybody
Yeah,
know
I'm
you're a
petty,
thief.
but I'm not a thief.
Everybody know you're a thief. Okay. All right. So here we go. Macro kernel for that one. Let me send you that link. All right. And now I just clicked on the link and nothing happened. Yeah. Same one. Okay. I wasn't too far off. All right. And then the next one I wanted to show you was this one. This one here talks about, so back in the day, this TLDP, if you ever just look up Linux or whatever, it's been around like probably like 30 years. Like, it's really old. Let me minimize and move over. Can you see that? Let me see. Let me get this out of there. Minimize that. Because it is. Okay, so this here, make it a little bigger. This is how they break down the kernel here. And the macro kernel doesn't do as much as the regular kernel does. And what was the reason for going to a macro kernel? Because of the bloatedness. So if you ever been to kernel.org, this is the latest and greatest kernel that you can download. If you're using Red Hat or CentOS, I don't even think they're on kernel version 4 yet. I think they're still on 3. They're always like really really far behind. But if you're on Fedora or Ubuntu, I think they're on the what they consider what they call the cutting edge. I think Red Hat is on something like 3.18 or something like that, and Ubuntu is on 4.4, maybe 4.16. They may be on 4.15, something like that, for their latest and greatest. But it does matter. So when new hardware would come out, people would have all these old machines and they would just buy the new hardware. And so what you would have to do is you would have to download a kernel. And if you ever played on your box, you get a kernel dev and incurses. So you'll get kernel development. You have to download that, and then you'll have to get kernel headers. Let's see, let me look and see. Recompile kernel Linux. Somebody got some notes so you can see a step by step of what you would have to do. So you used to couldn't have like wireless on your machines, like wireless laptops, and put Linux on top of it. It used to be a nightmare. So you always have to come in and recompile like your kernel and get it and install the driver and get it set up and then boot off that kernel in order to get what you need in it. Okay, yeah. So you have the modules you could do a make, and then you can do just make modules or make install modules. You can do those things, and then after you did all of that, and sometimes it would take 4 or 5 hours, then you can reboot. Depending on how fast it is, it's probably take about an hour. After it's done this thing, then you reboot, and then you're booting off that kernel, and it should recognize the new hardware that you install. So that's that again, going back to the importance of the kernel. So then Kemp comes along. Now we have microkernels, and this is kind of like where Puppet and Razor are coming in with microkernel, meaning like I can put the kernel. Well, you could do that now. You could do that before. You could put a whole operating system on a thumb drive, but it was just enough to get it boot, and then it would do a network install. But with the microkernel, it's enough to get it going and have some semblance of kind of like, I don't know if you ever heard of BusyBox, but have some semblance of an operating system where you can maneuver and do everything. And if you really think about it, think about your home switch, right? Your home switch has a little microkernel in it and just an interface that sits on top of it so you can do the things that you need to do. It pretty much is like a Raspberry Pi, really, sitting on top with some drivers for internet and other things that you need to do. But if you really think about it, that's really where that's at. So I also had this here for Linux performance, um, because I wanted to show you, uh, just branding stuff is great, but if you start looking at Red Hat's information, they kind of they gotten better with their documentation on explaining like, okay, in an interview, what is slash proc and what would I find in slash proc? What would I find in slash var log or what have you? And then they do a better job of like what resources you can use and how they can be used. And don't ever forget to just do like a man on these things or help or dash dash help on these IOstat, numstat. When you start getting into system tab and O profile and Valgrind, some of these have specialized kernels that you can download that are optimized for a certain hardware. So you may be running a certain bare metal machine, but it may have like if you go to like HP and Dell are good at doing this. They'll have optimized Linux operating not operating system, but kernel and or Red Hat system or Red Hat drivers optimized for their machine, so you can just do an install with those. So that's pretty cool. So just something to keep in mind when you start talking about bare metal and what's going on. Some people do have optimized stuff, so pulling stuff off the shelf may not be the best solution. You may want to go with the solution that that they've optimized already for that hardware. And speaking of, when you hear that, you should also hear when I say somebody's actually doing it. That's an actual job. Like that's somebody actual. There's an actual job to make sure that the latest and greatest operations or kernel that's coming out is optimized, and the OS is optimized for that particular hardware. And those are probably more vendor based when you start talking about Dell, or you start talking about Nutanix, or you start talking about HP, Hitachi. Those things, they're a little bit more optimized. Yeah, any questions from anyone? Is this over anyone's head, or does it make sense? All right. So the other aspect I want to talk about is security. All right. So I'll post that here. So what has come up often now is not only do you need to, as you are a security engineer, not only do you need to be the security engineer person, you also need to be the person that secures the operating system, the hardware, understanding the policies, understanding CVEs. Um, those are Those are important things. So I'll send you this. Oh, you are lost. Why you haven't said anything? Okay. All right. So this is just really a brief overview. Like I haven't gone into a lot of details, just giving you information, and then we'll start playing with some stuff here in a minute. All right. So as you can see, when let's get down to the contents. All right. So in here they talk about I know everybody is up on the Spectra situation, and remember that goes back to you upgrade your hardware or patch it, the the firmware or what have you, and then you get hit with a performance issue. So understanding how people came up with that that situation with performance, it goes back to the stuff that we talked about earlier with finding out what performance hit you're taking. I think everybody took a 20% performance hit. So, they had to go back and, go back and fix that. So that was a big issue that, it's still a big issue that Intel has to go back and fix. Now I bought the server to do X, Y, and Z from you, and your processor should be doing this. And then now you have me down 20% off the performance I had before. And then it was like it's still a vulnerability within inside of that. All right. So with the security aspect of it, you as the Linux administrator, you're gonna be responsible for the actual hardening of the physical hardware. And when I say hardening, meaning if I can walk up to your computer and turn it on and just log into it and do what I need to do, then that's a problem. So there's things that you may have to do to secure that. Like, so here they talk about securing the BIOS. But just remember, if somebody has gotten to the point where they got physical access, like literally physical access, like I can touch it to your computer, you got other issues going on before that. Now you may be on what we call in the data center and on the KVM, and somebody is hacked in, and you don't have like your your BIOS locked down, or operating system locked down, or you have just a plain a simple password or something of that nature, then that's a problem. So we talk about security from a couple of standpoints, also from downloading packages. One of the big things is, everybody now is downloading Docker containers, right? From Docker Hub. But here's my take on it is, how do I know that the container that I'm downloading that James built in Australia for Prometheus is a good container that I should use that doesn't have some type of secret spyware on it. And speaking of spyware, did everyone see the thing about don't use the ZTE phones because of security issues and so forth? Did everyone catch that from China? You know, like they're spying on you in the phone, and you just don't know it. Same concept here. Someone could be spying on you inside of a Docker container that you downloaded from someone, but you need to make sure that it's secure. So in the security guide, they actually talk about securing Docker containers, which I think is something that everyone should really look into when you're talking about you're doing Linux and doing containers and the movement to the cloud and so forth and so on. So I think that's something that you should really look at. Also, in this document, they talk about OpenSCAP. We won't get into that tonight, but we will be getting into OpenSCAP again. We will be doing Nexus scans as well too, and we also will be setting up monitoring services like using Zabbix. And I'm just talking ranting here, but let me show you Zabbix and Prometheus. And we'll be doing some containers this year as well too. We'll be building our own containers and deploying them. And I'd have to set up the class for that. So here's Zabbix. It's been around for quite some time, as you can see, 19 years. Trying to see if they got a picture. This is fine, but anyway, you'll see Zabbix monitors containers as well as Prometheus as well too. Uh, Prometheus. I want to. I can't remember if Prometheus. I know they're part of the cloud. I don't know if Prometheus comes from Netflix or not. I can't remember. I know that Kubernetes comes from Google. Spinnaker comes from Netflix, but I can't remember if Prometheus comes from Netflix or not. I think it does. But these are the two monitoring tools that I recommend. Everybody else has Nagios in their system inside of their environment to do what Nagios does. I'm just not a fan of Nagios. And then we have what we call Splunk for logs. A lot of people are using Splunk. So these are like what I'm going over are the basic things. Like once you learn the command line, these are things that you should try to, get some knowledge of and understand how they work and how to set them up and how to play with them and how to get things talking to them. And then start, contributing to, like, maybe you may write a plugin for Prometheus or something of that nature. So I think my personal take, and someone else may disagree with this. I think most Linux admins need to learn Bash, Python, and Go. You may come from a programming world, so you may know Java or Ruby. But one the things I look at it from a perspective of when I spin up a box in Linux, what's guaranteed to be on there? One, Bash is guaranteed to be on there, and I can get Python installed pretty easily. I can get Go installed pretty easily, but it's not native to the environment anywhere I go. So I'll write that in. Bash, Python, and Go. Are the programming languages that I think everyone needs to be, at least for one of those, you need to be really, really good at and familiar with. All right. And then containers. All right. So what I've also seen is a big surge in OpenStack and OpenShift. And when I say a surge, meaning I've seen phone calls for OpenShift people around probably like 6 or 7 jobs a week for OpenShift people, and doing OpenShift in various locations from New York to DC to Miami, San Antonio, and really big in California. So and because it's containers and then throw Kubernetes on top of that. And what I've been seeing is in terms of pricing is people are like, when I say pricing, I mean how much the job pays. Anywhere from 160 to 200 a year, give or take the region, what that looks like in that region. Sometimes, you'll get the unicorn and they'll hit you with the 250. So everything I'm telling you is kind of like a guide to where you can elevate your experience and elevate what you want to do and elevate your income. Now, when it comes to OpenShift, there's OpenShift Origin. That's the open source version of it. And then there's a Red Hat OpenShift. The Linux Academy covers, I think, the Red Hat OpenShift, if I'm not mistaken. Hold on a second. Let me log in. Any questions so far? I don't want to keep getting everyone lost and um, talking over your head. With OpenShift, I don't know how long it would take to learn OpenShift because I have not sat down and fully like, oh my God, I'm all in on OpenShift. I've been doing Kubernetes for the past month. So I think if you have a decent background in terms of, you can sit down and play. Well, let's look at it. It says it's 4 hours and 4 hours and 46 minutes. Or is this 4 days? Let's look at it. It's pretty long. I'm going with this maybe 4 hours. Let me look at the time on the side. And maybe 4 hours.
That's super short.
Huh?
Most of their courses are like 30 hours.
I don't know. Is this supposed to be 4 days and 4 hours and 46 minutes? Is that what that's supposed to be?
I think that's hours.
Okay, okay. I was like, 4 days, man. That's a lot of time. So I look at it like this. If it says 4 hours and 46 minutes, you might as well go ahead and just put a multiplier of probably like 5, maybe 10 on it, depending on how quick you catch. So you can probably spend 20 hours and actually get it down. And you're probably with this right here because it's an exam, and I don't know how long the exam is. Let's find out. Red Hat OpenShift exam. Let's find out. I'm sure it's hands on if it's from Red Hat. Let's see. United States. 3 hours. 3 hours. Let's see what they want. They want you to install and configure the container platform, set up the master nodes, configure OpenShift container platform so applications can securely be accessed by external clients, configure the node properties, create a simple OpenShift container platform project. Hey, you know what? If you study Kubernetes, I think you could do this. I really do. Because it sounds like this is like a Kubernetes type of thing. So, and that kind of leads into the next one. So, what Kubernetes is, let's look up Kubernetes. So, I want a visual. That's what I want. Let's see what's a good visual here That's the dashboard. And that dashboard is from this is this the dashboard from GKE? No, this is the GKE dashboard right here. So if you want to play with Kubernetes, there's a couple of ways to do it from my studies. Is the first things first is you need to learn how to install it and set it up. And what they do is they use Cube Admin or Minikube, but on the test, I think you need to do Cube Admin, and you can get it from their website. And I should be making some documentation on this, but here's pretty much a walkthrough for it, and it goes based upon the OS that you want to install with, and then you pick. Once you get everything set up, it's pretty straightforward. You have to install Docker. Once you install Docker, you need to make sure you install the updates. You need Kube control. That's what they have on here. Let's see, Kube CTL. You need to have that on there. You need to have QADM and then one other RPM or package you need. And then once you get all of that set up, then you can go from there. And then once you get that set up and you get the node set up, then you're free to start playing. And from what this class for OpenShift looks like, it doesn't look too far off from like you setting up Kubernetes and then playing with OpenShift. So once I get done with this Kubernetes stuff, maybe I'll dive off into OpenShift, and and we can set one up because their concepts are still the same. Like with OpenStack, I'm not OpenStack with with Kubernetes is everything is pretty much you got your nodes. So let's say I have four bare metal machines, and let me open up Word. I can find one online, so I don't have to draw it. Uh, So I have four bare metal machines. Those are considered nodes. And then on the nodes, I deploy pods. And within a pod, I can have multiple containers. So that's what they're trying to show here. So just think of my bare metal machine, or inside of GCP or AWS, I have my node, and then within inside the node, I would have a pod, and then that pod holds a container. So that's where you're looking at that. All right, so I see some stuff rolling here. Let me scroll up. How much Linux do you guys have? Do you work in the field? 0, that's okay. You came to the right place. We'll get you spun up. Don't forget to join the Slack group. If somebody could post the Slack channel link, actually, I'll just do it here. And then somebody says about 1 or 2 ways to AWS Cloud Practitioner and Associate Solution Architect. Okay. And yeah. So when it comes down to Linux, this is my story that I tell to everyone. This is what I think still works. Hence why you see me with these notes here. Anytime that you're studying something, right? I mentioned a whole bunch of stuff tonight. Open up a spreadsheet or a Word document or both, and put all your links inside of that spreadsheet and label it like I did up here. Like, what is an operating system? And then put your link inside of that Excel sheet. And then go over to your Word document and type that same question. And after you've done your reading, type in what an operating system is in your own words. Like every question you have is probably an interview question. And then you want to know where you got that resource from so you can go back and reference that. And so that's how you study. That's how you get to the level of being in a situation where you're like, okay, well, how do I study for this interview? Which leads me to the next thing. All right. So I pulled some jobs. And see, it's got cut off over here. I pulled some jobs that were sent to me, and so I'm going to. I'm gonna let you respond to me, right? I want you to tell me what you think of these jobs and kind of uh what kind of environment you think it is, because it's important. This is important when you're looking at jobs, when you're looking at where you want to go, and then it's also important of how you see yourself in that position. So let's talk about it. All right. So here it says they want a Linux system administrator. First, it says no remote, no, and I'm assuming no telecommute. They want a Linux system administrator with 3 to 4 years working in a large, fast-paced production environment. Must have strong experience with attached and SAN related issues. All right. So first things first, 3 or 4 years. Some of that can be waived if you have an actual certification, or you may have experience as a programmer in the environment, or you know someone. So there are different things that can happen there. All right. Now, when they're talking about the SAN, most people don't have a SAN sitting at home, nor do they have a way to uh, get a SAN at home. However, there are ways around this. So it's called NetApp SAN Simulator. You can actually download it and play with it. I hope this. But anyway, if you went here, it'll give you a simulator of a SAN to play with, and then you can simulate. Like I carved up different partitions on a SAN, and I presented that to an actual VM, and it mounted. So now you at least have some concepts behind that. Another thing that often comes up when we're looking at jobs, they don't have it in here, but they do have Red Hat or CentOS 5, 6, and 7. Solaris, that may be Solaris 10. The Veritas is the backup, and it's being a clustered environment. And everything that you see here is probably out there for free for you to do, like a specialized training on it for like 30 days or something. But we're going to get into that. The other one that you can always get, that you get free training on, is VMware training portal. It's free. It's posted it's posted inside of the Slack, but I don't think it's this one. There's another one. Um, because they have like an introduction to EXI6, and like it's not really even an introduction because it's like 200 modules, and it walks you through, and they have an education environment where you can spin up the environment and play with it and get a full blown uh learning environment for and maybe my VMware Learn. Look. It's posted in the Slack. If somebody go to VMware in the Slack group and look up my VMware inside of the VMware Slack group, you would see it. And if you could post it, that'd be great. But I say all that to say that this is just a way for you to get um let's see. Uh-oh. I don't know why this not working. Hold on. Let me cut and paste. That's one of them. But there's another one. Yeah, this is not the one. If you keep scrolling up past this link that's in Slack, there's another one, but this is a good one too. So you can see here you got vRealize, on demand, how to set up, install. There's still jobs out there looking for people that have VMware. Some people are still on VMware in a private cloud and not moving to a public cloud. They're still wanting that person to come in and help out with that situation. So let's go to the next one. And these things that I'm showing you are just free ways that you can say, okay, I got a good gist of Linux, but once you start learning Linux, you're gonna pile on these different things on top of it. And this is just an example of, someone needing to have some Red Hat experience, but what else do you need? You need some storage experience. You need change management processes. And uh, I know Paloma knows more about the change management process. It can speak on that more than I can. I do it, but she's in a much stricter environment than I am, so she knows that too well. All right. So now here's the next one. So there's an AWS architect, right? So this AWS architect needs to understand AWS, but you know what else you need to understand? You need to understand Linux too. So it's kind of like it go hand in hand now. Like I'm a Linux cloud person and security. That all of those things go hand in hand with each other. Um, this VDI, this is the VMware Horizon. Again, that's the VMware stuff I talked about. There's a class out there for it. The Windows Server stuff, you can take that on Udemy, or you can take it on IT Pro TV. Let me go there. ITPro.tv, or maybe just IT Pro TV. Yes, ITPro.tv. All right, so they have classes on pretty much everything. From Let's go down to the Windows stuff. So there's fundamentals, there's server networking, and then you see the hours. They're all videos. There's somebody talking, and then they have their own labs. So you can run through them if you're looking for Windows stuff that Linux Academy just doesn't offer because it's Linux. A Linux Academy. They may offer some Azure stuff, but they don't offer like a MCSE or a SharePoint type of situation. Pluralsight as well too. All right. Let's keep going down. All right, that's another one. That's the architect. All right, cloud automation. So goes back to what I was talking about before. They're looking for someone with Python, Chef, Ansible, understand the experience with Azure subscription servers using Python. In other words, can you write Python? Can you use Python and then wrap the actual utilities up into a Python script from command line, like using AWS CLI, understanding the managed services, and identity management. And these are all these things right here are all things that you be using Python for, unless you're in a Windows environment. And even in a Windows environment, you may use Bash. Again, there we go. More automation stuff that you would need, and understanding APIs. Here we go. Microservices, talking about Kubernetes, Go, being able to do deployments, breaking apart monolithic applications. And then here's a DevOps manager. Trying to give you a variety of what I see that comes through my inbox of what people are looking for. Pluralsight was looking for uh, what is what they a diversity and inclusion person, but they wanted that person to also have some type of engineering background as well too. So it's just all kind of stuff out there. Any questions on what we were discussing, or what I just went over? No? All right. So let me hop on the terminal here. Does anybody have a machine they can log into, or you need a machine? No? All right. Let me get my IP address. And Jordan, do you have a window? Are you on a Windows box or a Linux box? You're on a Linux box? Okay, well you should be able to just open up a terminal. Let me get some IP addresses. Hold on. Oh, all right. So you don't have to type H. There's nothing special about that. All right. So this is my digital ocean machine, and I'm on these laptops, so I can't use my keys. So sorry for logging in as root. All right. So this is my Ubuntu box. As you can see, it's a Kubernetes machine I was playing with. And this is Ubuntu. And I do have one for CentOS, but so you have to bear with me because I'm a CentOS person. All right. So CentOS uses Yum as its package installer, and then Ubuntu uses apt-get. So I don't know what you all are in. What if you could type what flavors you're in, that would help, so I can tell you what commands to type as well. But if you are, or if you have Linux on your laptop, you're probably in Ubuntu. So let's do an apt-get and let's install, and it may already be on here. wget. Yeah, that's already on there. So let's talk about some things in Linux that you'll probably commonly use. You'll probably commonly use these things here. And let me make this a little bigger. Is that better? And let's take this and go over here. And go here. All right. So we know a couple of things. We know ls, don't capitalize, pwd, cd, I with the capital here, ls, pd, pwd, cd, make dir, and we're gonna run through these commands really quickly. And then date is another one. What else do you use? Michael Jenkins and Paloma. Let's see. Tracy, what else do you use? Who is another command. Which is another one. We're gonna run through these. PWD. Oh yeah, cat. And let's do cat real quick because this goes back to a conversation we were having earlier. So if I go over to /proc, cd is one of the commands there. So it's cd, and let me back up a minute. Let's go cd to /, and then let's do a ls, meaning I'm going to the tip top of my root of my directories, and I'm gonna do a ls. And what you see is you see a list of things. I say things because you don't know. I'm making the assumption you don't know what they are. But I'm going to give you a way where you can find that out really quickly. I can look at this and eyeball and tell you I see some directories and links, but I'm really not sure if I'm seeing directories and links. So I can do what they call ls minus f, capital F. As you can see, it ended up putting slashes behind some directories. Well, putting slashes behind some things, which lets me know they're directories. And then it went and put some @ signs behind things, which lets me know they're links. But guess what? I'm still really, really not sure if that's what that is. So let me clear my screen and do a ls minus l. All right. So now we see some different things. We see a whole bunch of stuff. And let's talk about this. Remember before I said we saw this with the slashes, and we could probably scroll up and catch that. We saw these the slash behind it. And let's go down here to lib64. Now here is my lib64, same as what we saw up top. And we can see that the D out in front, that lets me know it's a directory. So I could look at that before eyeballing and tell it was a directory. A couple of things that led me to let it know it's a directory. One, just the color in this particular terminal. Two, I just automatically know because you've been around it long enough, you just know. And then the surefire way to figure it out is you do the ls minus f or to do an ls minus l. Now, another thing you see here is you see up here that, and I guess it's kind of like a greenish tint, blue-green tint. You'll see init rd.img, and it's pointing to another location. Well, the other location that it's pointing to is actually where it lives at, but all it is a symbolic link. Now, there's some differences, and we'll probably get into this a little later between a soft link and a hard link. But we'll get into that at a different time. I don't want to get into that today. I just want to show you some things, some commands that could help you maneuver around the command line. And then we'll end it with my favorite. My all-time favorite is vim. Yes. All right. So in order for me to clear the screen, I type clear, or I think is it Command L that clears it? Is that it? Hold on. Yeah, Command L on my on a Mac is Command L. All right. So I went over ls, and I'll do it again with ls, but I wanted to cd to /proc. No. So we're gonna go cd over to /proc, right? And if I want to get a listing of what's in that particular folder or directory, I just do an ls, and look what happens. Now, from eyeballing this, what we just went over, can you tell what's a directory? Can you tell what's a link? And then the other things that you should have on here are files. So you should be able to tell the links to files and directories just by eyeballing this. So with that being said, I told you before I wanted to find out, I want to show information. Let me give you some caveat here. Proc is your real time system, like is what's actually going on right now. So you can pass commands or you can change things in slash proc that'll take effect immediately. The only problem is once the server reboots, it's gone. So just something to keep them in mindful of. So let's cat CPU info. All right, so this tells me, more about my CPU, what flags are being set. Like I tell you what type of CPU it is. Also, it gives you a little bit more information about the processor and so forth. So these are things that you can see over here. The vendor, the version as well too. The E5 model name. So it's just a little things that you can find out. Why is this important? Well, if you were on a bare metal machine and you needed to set up your machine to take care of virtualization, you need to make sure that your CPU can handle that as well as, going into the BIOS and turning it on. That's where that comes important at understanding that. So let me clear. So let's do a cat proc and let's do mem info. And so here is where we get information about the machine and its memory, if it's what's eating up what, and the good place to find out all about the mem info and the CPU Linux performance was that link that I had with Brandon Gregg. That's gonna give you like your stuff that you're gonna want to dive off into here. And then let me here. Perf is another one that you want to look at. Yeah, this right here and understanding perf and all the other tools and so forth. All right, so now let's get back to what we were working on. We were working on what's inside a slash proc. We can find out about let me click on here. I'm just going to do the whole directory because I'm there. So I did a cat on slash mounts, so you can see what's going on, what's mounted on this machine, what's going on here in real time. This is all real time stuff. You'll see my Docker stuff that I have here. Also down here I have date. So if I type the date command, it gives me the date. But as you can see, this in UTC time, and you see the time is off, and that's not the right time, right? So it's called date. I think it's called date control inside of Red Hat is you do the time zone change. Let me see. Do they do it here? Your time date control. Let's do a -- help. So they say I can set the time zone. So let's do that. Let's do set time zone. Let's do list time zone first. And it's gonna list all the time zones, right? I know I'm America, New York. Let's cut and paste that. Let's clear that. Let's do time, date, control. And it was set dash time zone. I just did a double tap on that. And then I chose that. And then let's go back and do date again. And now you can see that my date has been changed. My time has been changed to the East Coast time. And it was just that simple. All right. The other one is I have on here is who. So let's clear this and we do who, and it tells me who I am as well. And if I was another user, it would tell me. If I was another user, it would tell me who I am as that user. If I do a W, it tells me who's logged into the system and actually, the commands that they're running at that particular time. And Michael Jenkins brought up which. So here we can say which Java. I don't have that installed, so let's see if I can do which wget. Yeah. So I had installed wget earlier, earlier before here, but it's installed, and which is in the path, and so is wget. So it tells me when I run wget command, it's coming from user bin wget. That's what that's telling me. And then I just showed you the cat command, but what I didn't show you was let's look at uh we can do a vim on var log messages. And that's a way to open a file and view it. Oh, I don't have messages. Let's see what I have over there. Let's do a last log. Ah, that's coming from this. That's a bin. So if I just run last log, tells me who logged in last, and it's reading last log from var log last log. It's reading that file. So let's go over to var log. All right, we can read the syslog. Let's just read syslog. All right, so inside of syslog, really syslog gives me it's more like I guess you could consider it like a service that logs everything, and that service that logs everything is coming from etc rsyslog.conf. And in here, scrolling down, you'll see that I have worked these files, but it's telling it to log the var spool log, etc rds.syslog.conf. That's included. So let's go over there. Let's look at that real quick. All right, let's look at the firewall. ufw.conf is the firewall inside of Ubuntu. And it's telling the firewall when it does its logging, make sure you store everything in var log ufw log. Now I turned off the firewall on here, so there shouldn't be nothing in that one. We can do what we call a tail dash in the last 10 lines of var log ufw log. Is that not there? Yeah, nothing there. I got it turned off, so it's not logging anything. But we know syslog is there, so let's do it on syslog. So all it did, I clear my screen here. Clear. All we did was write the last 10 lines of syslog. So that's just some of the commands that you'll use in Linux often. I use vim as well, so let me clear my screen. When you go over to /opt, is usually where I put anything I want to use, or I make a directory or put it in my home directory. So let's vim my test.txt. All right. So I have this file, and now I'm like, okay, how do I make an insert, or how do I write in this file? Well, before we get started, I want everybody to know there's always the good old handy dandy Vim tutor that lets you. I don't have it installed. Oh, yeah, there it is. That lets you walk you through on like how to move around inside of Linux, what you can do, and not inside of Linux, but inside of Vim, how to get out and so forth. So I did an escape. I did a shift:/Q exclamation point. Now there are different editors. Somebody brought up Nano. Pico, and other editors. The only difference is like from an admin standpoint. I don't know if Nano is going to be on that machine or Pico is going to be on that machine. I know for a fact Vim is going to always, or VI is going to always be on every Linux box. It's just what it is. So most people stick with VI. People that are, I guess, what you consider Nazi purists or just purists, they kind of stick with VI.
Lazy,
What'd you say?
lazy people.
Lazy people stick with VI? I don't
Yeah, they
know.
don't want to.
I don't know. Is that lazy or is that just like I just know VI is going to be on every machine? What is considered non-lazy?
Nah, I will not take any Vim disrespect in this conversation today.
Exactly.
No, we're disrespecting VI.
No Vim. I use Vim every day without fail.
Without fail, it is the go-to thing. So you heard it from more than 3 people, including the ones in chat. Vim, hands down, no disrespect in this. Our Vim rules. All right. So just like a brief overview of what you can do when I say you can have a Linux career. Paloma and Reggie are testimonies to that. Shania, you're on your way to being a testimony of that. Tracy, come on over. You still over there trying to do the web dev stuff. I get it, but from another web dev to another web dev, I would let Reggie take control of that conversation and have you come on over to the infrastructure side, where where you can breathe.
Life is a lot better.
Where you can breathe. And when I say infrastructure, let me talk about that. All right, because there's a what I call I guess you could consider it like a new wave, right? So there's the automation engineer, which are your Puppet, Ansible, and Chef, or Terraform, or what have you. And then there's this break apart the automation engineer and this new infrastructure engineer. So that's been coming up a lot lately, and I just go to Indeed because it's quick and I don't have to do a whole bunch of signing. So infrastructure engineer, you see their manager automatically pops up there. So as you can see, they're all over. Atlanta got 800 positions for it. There's 1,000 positions in Chicago, California. You see Amazon got JP Chase Morgan, and by the way, JP Chase Morgan has got a lot of positions open, and they're hiring left and right. I know they're slated to do at least 10,000 new hires, and they got a big contract, so they may jump up to 40,000. So it's just like FYI on that. JP Chase Morgan is hiring, and they're hiring left and right. Goldman Sachs has been doing a big surge as well too. So these jobs, like look at there's 10,588 senior level jobs for infrastructure engineer. Then it falls, like it gets crazy, and you start Napa Auto Parts. Thought about it, but hey, they're looking for somebody. I think somebody posted the other day in another Slack. What was it? Little Caesars, one of the DevOps engineer. Uh, the jobs are out there from the infrastructure side and from the automation side. I've been seeing a lot of that. And then the cloud side it's still AWS, but I've been getting a lot of Azure. A lot of people are looking for Azure, and a lot of people are looking for uh, infrastructure engineers that understand blockchain. So that's been really huge. I've been seeing one every 2 weeks on blockchain. So don't let like you looking at Linux and you say, okay, what can I do with it? I'm telling you, you can do so much more by adding on a tool. Get really good at understanding the command line. Get really good at understanding the kernel and how to manipulate, like if it's a process running too high, understanding the performance tuning. Get really good at those things. If you get really good at performance, security, um, and tuning for Linux
Networking.
and
Sure.
networking, let's back up. Linux performance tuning and gosh, I forget what the other one I just said. But anyway, those three are guaranteed jobs. Now, here's where you add on. So networking to me is like just a basic skill that I think every Linux person is supposed to have. Like that's just me. Understanding how traffic routes. If I'm sitting on a server and I can't get to another server, or how can I ping? Can I use Wireshark? Can I get to a port on that server? How are things laid out? Is there a firewall blocking it? How do I troubleshoot that? Understanding troubleshooting and adding tools to help you troubleshoot that goes a long, long way. Like that thing is that's a lifetime career move. Like you're gonna always use that. You're gonna always be able to walk into a situation and understand how to do that. So the things that I showed you tonight are tools and situations you can put on top of your basic Linux skills, but they go very far and they can go in any environment. Like I believe in being agnostic to environments. So some people believe in being a specialist. I like being a journalist, being able to walk into a situation, understand it enough. If I need to dive off deep, I can dive off deep because I understand the basic concepts. When you start understanding basic concepts, you'll go very far. And understanding basic concepts is the networking. Understanding basic concepts is the troubleshooting. Understanding the basic concepts of how to write a for loop. How do I get how do I monitor 5 machines versus 10 machines versus 200 machines? How do I get information from 200 machines versus the 5 machines? 5 machines I can log into, right? Well, yeah, that's cool. But now I got 100 machines I gotta log into, and I gotta get the same information for them 100 machines. How would I do that? How do I automate myself? Anytime you do something, rule thing is anytime you do something more than once, you need to write a script for it or you need to automate it. However you automate that, and keep your own documentation. And don't be afraid to write your own documentation and take it with you, even if it's like, hey, today, write down in a file somewhere. I learned, how to get Kubernetes to talk to Spinnaker, or I learned how to get AWS load balancer to load balance across, 4 different types of machines or something. Like anything, like it, write it down on how you did it, screenshot, whatever. Be your own walking encyclopedia. So when it comes down to studying for an interview, and I study, you can say, oh, let me just go through my notes. Oh yeah, that's what I did. Oh yeah, 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 yeah. And then after a while it just becomes second nature to you. Anybody got any questions? Yeah, basic is always a good thing. Like, oh man, like I don't know how you go from, I don't even know how you get to expert without being basic. Like that's just you gotta understand basic knowledge. Anybody got any questions or anything they want to add?